Okay. What's the question? Is there a question? Oh, what numerically in kilograms does an AMU equal? Hint, the rear cover of book. Oh, maybe it's on the cheat sheet for this chapter. Maybe you don't.
Maybe we'll have to do some dimensional analysis.
Yeah, that's what it sounds like, don't it?
Somebody, I forgot who it was, some student around here that said that their old teacher, hated dimensional analysis, thought it was stupid or something, and I was like, what kind of freaking professor in the right mind thinks it's stupid?
I've heard that storyline too, that some people just don't, absolutely refuse to teach dimensional analysis.
It's like you don't know how to use it, apparently.
See, in fact, when I was at grad school, you know, you're timed on, every grad school is different, right? So I was taking these diagnostic exams in PChem, and you have all these international people around that are really, they've taught the course before or whatever, and it's really strong, right? So, you know, they taught the course in China or whatever, but they have to take whatever. I don't know what the story is. But anyway, these guys are really strong sitting around here. And you're taking this exam, and there's this big, long-ass integral. So I'm sitting there looking at it thinking, right? I don't remember all these trig relations and all this stuff. So I had to do it all by hand. So then I was just looking at it. And you could solve it by dimensional analysis. So that's what I did. How many points do you think I got?
Not a lot.
Not a lot. F. Right?
Hey, they should have gave you points for being creative. Stupid idiot. You got it right, though, right?
Yeah,
Right.
I got the right answer. How did you get this?
It's like, I don't know.
Yeah. All right, so I don't know if it's on the cheat sheet or not here. Oh, there it is. It is on the cheat. You might as well use this cheat sheet. This is what you're gonna have. It's on there. You should rip this out. It's on page 22.
For this chapter?
Yeah.
Okay.
It's on page 22, and it's on there. You see it? Up there where all the constants are.
Yeah.
But the book doesn't call it an AMU. The book calls it what? Oh, let's follow it. Okay, hang on. Let's do what the book wants. Maybe let's do it this way. Maybe I'm supposed to derive what's in the cheat sheet. I bet you I am.
Oh, they call it U?
Yeah.
Yeah, we're on 11. I already told her that. Oh. They call it a U. Okay.
They call it a U.
One U? Well, that's a symbol. I don't know what they call it.
A micro.
I looked it up online because I couldn't find it in the book, and it said 1.66 times 10 to the negative 27 kilograms.
Yeah. Which is
Yeah.
one U.
But how do you get it? I bet you. Go to the inside front cover. I think, yeah, we can't. Sorry. The cheat sheet is using the result of the concept preview. So we got to get the result. We got to get the concept first. Sorry. All right. So you need the inside front cover.
Oh yeah, it was right here. Oh.
No, I can't see it. I don't know if my useful relations are coming up
Check
somewhere.
the cheat sheet.
Okay. All right. So do you have the inside front cover? The inside front cover. See, everything's, like I said, everything's supposed to be based on carbon, right? Carbon 12. And this thing says that if you look at the rear cover there, it has, the table has, for carbon, you have, it's carbon 12, and it's 12 U units, right? 12 AMUs. Okay. So what would 1U be? 1U would just be divided. Well, you divide it. 1U would be 1/12 of this. Okay. So if you take a look at how do I get this? So if you take 12 U's, if you divide get the mass of one atom, don't you have to divide it by Avogadro? All right? You have to divide it by Avogadro, and that would be the mass of one carbon atom in U units. But remember, a carbon atom is 12 U's. So not only do you have to divide it by Avogadro, you have to divide it by 12 too. Right? I think that's how I got that number. Try it.
Yeah.
See, right? Does that make sense? So,
Cool.
okay, now watch your units though. This is 1.66. If you do this, you get 1.6606 times 10 to the negative 20. If you divide that out, 24 grams. But the question didn't want grams. The question wanted kilograms, right?
Yes.
Well, I don't know where the hell it is. I can't even find the question. So how do you convert grams to kilograms? Move it over 3 over, divide by 1,000. So not 10 to the negative 24 anymore, but 10 to the negative 27.
How did you get 1.66? You multiplied 12 times
No, you divide.
oh.
Well, you can take,
Yeah.
see what we're trying to do is find 1 U in kilograms. So,
Oh, there it is, number 11. It says what numerical kilograms does an AMU equal?
yeah, there it is. This is one we're doing. So it equals 1.66 times 10 to the negative 27 kilograms. Okay. Now we're on 12. Oh, yeah, we cheated. We shouldn't have looked at the cheat sheet. But it's on there. So an AMU is simply written, is also written as U, the book, that's what they like to do. So what is the atomic mass of chlorine 35 in units of U? So these things you can't memorize. You got to Google it, or you got to just look in the back of the book. Do you see it? 34.9688. So 34.9688. So in atomic mass units, that's the mass of chlorine 35. What is the mass in kilograms of a single chlorine 35 atom? Hint, use your answers from 11 and 12. What would you do?
You get the number from 12, divide by Avogadro, and divide it again.
Whoa, 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 whoa. We were just talking about dimensional analysis.
Just multiply grams by 12.
Yeah, but
Oh, yeah.
I think the answer that we just got from 11 and multiply it times 35, yeah.
That's what John just
yeah,
said.
yeah.
Yeah.
Because then
I
the
don't know what John
because then the
said,
little u's
but it
cancel,
doesn't matter,
right?
So. I wasn't paying attention.
But see, these when you do this sort of thing, for me, this is a really common mistake because you do stuff in your head and you screw up. So I force myself to do the little box thing because it takes 3 seconds more, but I never screw up, right? Because the U has to go down here,
Yeah.
Awesome.
right?
But dimensional analysis is
And then-
useless, so you should just stop while you're
Just don't use it to solve an integral and you'll be okay. And then you have kilograms, right? The mass. So you can use this table, or you can Google the atomic mass units of any atom, right? And convert those atomic mass units into kilograms. And why are they messing with kilograms?
Physics.
Because physics. What's the standard metric unit of mass? Kilograms, not grams. So that's why we're all hung up on kilograms.
United States.
Okay.
You get a problem wrong with that.
Yeah.
Yeah, it is.
Euler's formula can be written as e to the I phi is cosine phi plus, what's I again?
The square root negative 1.
Yep. Okay. Use Euler's formula to show that the integral from 0 to 2 pi of e to the I phi is d phi. Okay, so what would you do?
So just put in cosine
Mm-hmm.
I
Into,
EI.
yeah, into the integral, and then integrate it. And hopefully you get 0. Let's try it.
Hopefully you get 0.
Yeah. If you don't visit now.
Can you help yourself out by making that 2 integrals? Yeah, if it's easier, I would. Right? Anything that to make those antiderivatives look easier, I do. That's gonna be kind of gross. You just heard me drink water.
What?
On your introduction.
No, if you listen to this.
It's gonna be on the video. It sounds like a dog drinking water.
Way to go, Ricky. Do you have your comments disabled on your videos? Like on the comments?
Oh yeah.
Is that a dog drinking water?
So this is easy.
Maybe I shouldn't disable them. Might make people watch more stuff,
Yeah.
right?
Yeah, and now you can get good feedback.
Well, I'm not looking for feedback. Just people to have fun, and then they can.
But then again, there's people
The more.
Yeah, you're right.
Rude.
Like on YouTube,
Yeah.
there's like stuff that's amazing, but there's like all these.
Yeah, but who's gonna watch chemistry with Dr. Smith and make negative?
I watch it.
No, and make negative, stupid comments.
Yeah,
They're not gonna waste
people-
their
like,
time
people
on that.
making Comments like, what have they ever done that ever did anything remotely?
Yeah, I don't think they would watch.
They're just there to be negative. That's true. So is this as easy as it looks?
Mm-hmm.
Oh,
You get 0?
not yet.
I would substitute it right at the.
Well, the I. What can you do with the I? Pull it out of the.
Oh.
Pull it out of the integral. It's not a phi.
And then sine is negative cosine.
Derivative of what gives you sine? Yeah, it'd be negative cosine. We're doing 14.
Let me see. That's you know how slow I am, dang it.
But okay. I like two.
Yeah, you get 0.
So
Got
Dr.
0?
Smith, do you really play disc golf?
In fact, you know what I just bought? I got to tell him, Brad, I got this cashback rewards, and I love spending because it's like free money, right? You buy whatever stupid ass thing you want to buy. So I Googled, because I go play with the old men, right? So I want to cast it 10 times farther than them. So I Googled what the world record disc golf is.
Whoa.
And I found it on Amazon, and I ordered it. That's what I did.
The world record disc golf. What?
No, the disc.
That's the one with the chain, right? And you.
Yeah.
That's ultimate frisbee and disc golf are the same.
I've never heard of
I don't
ultimate
think
frisbee.
So disc golf is the one where you're trying to hit the chain basket. It looks like a basket.
Yeah.
And you hit it
Yeah, there's no catching in disc golf.
And I made one yesterday from like 60 yards away.
No
It was
way.
amazing. I was like, wow, I couldn't hit anything, and then all of a sudden. Just
See, now with my world record disc, that could have been 120 feet away.
But your aim still has to be good.
Yeah. Ah.
You didn't buy your hanging upside down machine?
No, I read that it's bad for your eyes.
Really?
Batman.
I was
Batman.
gonna get that,
Ooh.
but I heard it's bad for your eyes.
I didn't know that.
Really? What happens?
I don't know, pressure builds up.
Pressure
Yeah.
From, I guess that would make sense. It sits on the top of your head.
Yeah.
Not the bottom.
Dude,
All right.
it's a small limit.
So everybody got 0?
Go ahead.
Yeah, I got 0.
Okay. Two masses, Ma and Mb, are connected. What is their reduced or effective mass? Hint, see page 28. Or maybe the bloody concept preview. Yeah, there it is. It's on the concept preview. Reduced mass has... Reduced mass is symbol mu on page 28 in the book. And I'm just looking at the cheat sheet here. Okay, so why use it? Physics used reduced mass. When? When did physics use reduced mass? Do you remember seeing that little mu and plugging that into the equation for mass ever? It's the reduced mass, it's the effective mass, it's the mass when. Whenever you have, let's say you've got this object, you're trying to explain this motion, right? Oh, that's not a bad example. Let's call it A. They need to be different. A and little b, right? Just a molecule, and it's got a bond, and it's vibrating, this bond is. Going in and out, right? Well, to explain the motion of that, do you use the mass of A? Do you use the mass of B? Do you use the mass of A plus B? Do you use the mass of A, right? What mass do you use? When you have motion, you use reduced mass to explain when things, you don't just have A. We just had one thing flying around. It's pretty easy. Just plug in the mass of A, you're done. Because all these equations, M's everywhere in physics. F equals ma, right? You've got torque, you've got angular momentum, now you've got things moving in a circle. Oh, geez, right? So what mass do you plug in? You plug in reduced mass. And for two objects, reduced mass equation looks like this. And we're just going to be messing with two objects. So when you have motion, you have to use reduced mass. So we have all these equations that you have little m in, and if you have two objects and they're moving with respect to one another, you don't plug in, for that little m, instead of plugging in little m for mass, you plug in, what do we call this? What symbol? Mu. Plug in mu. Okay. So two masses, Ma and Mb, are connected. What is their reduced or effective mass? Well, I guess you just have to plug in, well, here's the equation right here. Then you'd have to solve for mu, I guess, right? Okay. If Ma is, what does this mean, double arrow? How are you supposed to read that? If Ma is what, then Mb?
Much less than.
Much. You have to use the word much.
How do you know that?
All right. If Ma is much less than Mb, okay. If Ma is much less than Mb, what would this expression for mu get reduced to? All right.
Are we solving for u?
Yeah, we want to get mu. Yeah, you want to get mu out of this thing. And Ma is a really tiny number in comparison to Mb. So what?
Would you multiply MA by something?
Well, hang on. Just look at when you. It's that trick where you have a really big number and you're dividing it by a really big number. If you divide by a really, really big number, you get a really, what number? MB is, pretend MB is huge. Well, it is in comparison to MA. MB is huge. You end up getting, what's 1 over MB then? Really, really? Really, really small. Like 1 over,
So what if they both have
Because MB is large.
right? And
So you just make it equal to 1.
so you see the difference here? I want to calculate this. What do I not even need to look at, pretty much? Just say it's 0. Which one? Yeah, the one on the right. Because I do this one, I'm going to get, what, like 10,000 or 1,000 or something, right? So 10,000 plus 0.0001, I got 10,000, right? So this guy, you can pretty much, you would just go to 0. So we do the same thing here. Which one was the really big one? Was it MA or was it MB? Right. Which one's much, much bigger? Is it MA or MB? It's MB. So we can say this guy goes to 0. So we end up with 1 over mu is 1 over MA. So what will mu be solved to be equal to? MA. Right? Do that diagonal story. Remember playing with this? That goes up there, this goes up there. So MA equals mu. See that, Ashley?
So what, like, in the book it said half M, what did they mean by that then?
I'm not sure what you're at. But the point is if you have an electron and a heavy nucleus, the electron's going around the nucleus, which one's heavier? The nucleus or the electron? The nucleus, and it's a much heavier thing.
Just ignore the electron
So you
calculations of the atomic mass units and stuff.
wait, you missed the point.
Yeah.
Are they ignoring the electrons?
No, it's just that it's
No,
so
the reduced
small.
mass is the. No, you don't see it. What's the reduced mass of an electron going around a nucleus? All you care about is the mass of what? The electron. Right? Because, see? Because the nucleus mass is huge.
Oh,
So it's a very odd thing. But this is physics. So when you take the so what's the answer for this? MA. Okay. So what I'd like you to do is take a look over this, everything that we've done here, and then I'll give you a quiz over this. And looking at it, I saw that we didn't have a whole lot to go over, so I figured we were going to have a lot of time. So this is pretty long. So it might not want to review for too long, because there's a couple things on there that might take you a little while.
What's number 9?
Show that this has units of frequency. We did it right here. 1 over S.
Oh, yeah, that's what I got. Put it in the wrong place.
We just review it all. Review how you worked out a lot of this stuff. And when you're ready, just grab one of these. And then we'll staple the concept preview to the back of it. And we'll call it a day. When you're done, just staple the concept preview to the back. So if you do the algebra, you should end up seeing that joules equals joules. Or meters equals meters, or kilograms equals kilograms, however you want to cancel stuff out.
What's a joule? It's a kilogram meter.
Right here.